Hi guys, welcome back to another video. It's H4 Maths. Today we're going to be discussing hypothesis testing, more specifically binomial distribution, right? In the A-level maths syllabus, we need to know the normal distribution, the binomial distribution. In the further maths relating to hypothesis testing, we need to know the Poisson distribution, and this method can also be applied to the chi-square test. Right, so what actually is a hypothesis test here? You might have been in class, or you're starting new right now, you're trying to understand what hypothesis test is. What is it? Well, what it's saying is basically, we're going to look at a claim of the probability, and we're going to see the probability that that claim is true under a certain hypothesis. Now, those are just words to you, so I'm going to give you an example. Imagine we have a coin toss. Now, assume that the coin is fair, right? What would the probability of getting head be? It would be, because it's a fair coin, P equals 1/2, right? 0.5. Let's say we run a little experiment here. We toss a coin 10 times. And then let's say we get 9 heads. Okay, using our intuition, we may say, the coin might not be fair. Well, we want to conduct a hypothesis test to test that claim and see the probability that the probability has actually changed. For binomial distribution, we're focusing on binomial in this video, but again, the hypothesis testing can be used, this method can be used for other distributions as well, such as a normal distribution. In order for binomial distribution to work, guys, you must remember there has to be a fixed probability of success. When we throw that coin, it'll be 1/2 each time, assuming it's fair. There has to be a fixed number of trials. Okay, we toss a coin 10 times in that example. And there also has to be independence within each trial. So the probability of me tossing that coin the first time and then the second time, they're independent of each other. One doesn't cause the probability of another to change. Okay, so let's say we're going to start off with a hypothesis test. You guys need to remember the H0, okay? This is called the null hypothesis. Now, the null hypothesis, what actually is it? You might have heard it. It's a probability that nothing has changed, okay? P is going to be equal to 1/2. Nothing has changed, okay? We're rejecting the claim. In this example, we've claimed that probability might not actually be 1/2. We might actually get a higher probability of getting heads, and the coin might not actually be fair, okay? So we have the null hypothesis, 1/2. Now we're going to look at the alternative hypothesis. Alternative hypothesis. It's in the name, okay? It's going to be different to 1/2. It's going to be our claim. I'll claim that the probability is going to be bigger than 1/2. I've claimed that. Using that experiment, using my intuition, I'm claiming that. And we want to see the probability of that claim being true. Okay? So I've said that the probability is above 1/2. That is the alternative hypothesis. So now we have these two hypotheses. We're going to conduct our hypothesis test. So, what do we do when we conduct a hypothesis test? Well, we're going to find the probability of the probability being bigger than 1/2, assuming that the probability is 1/2. That will make a bit more sense to you as I go through. So we're going to say x is the discrete random variable that follows the binomial distribution of 10, which is a number of trials, and 1/2. I've used 1/2 here because in every hypothesis test, you are assuming H0 to be true. We've assumed H0 to be true. Okay guys, so this is what the distribution will be following under the H0 hypothesis, okay? X follows a binomial distribution of 10, 1/2, and 1/2. 10 is a number of trials, 1/2 is the probability which we've assumed to be 1/2 because we've assumed the coin to be fair. Okay guys, so we're going to find the probability. Gonna get another pen. The probability that x is bigger than 9. Why do we do that? 9 is what we got in that little experiment of ours. We tossed it 10 times and we got 9 heads back. We're going to find the probability that we would get 9 heads back. So it has to be greater than or equal to the x value. Because remember, we're dealing with discrete, this is a discrete distribution, none of my pens work. So yeah, we're going to see 9 or above, okay? We got 9 in that experiment. Imagine we got 10. It's either 9 or 10 because we did 10 times. And we're going to see the probability, I'm going to draw the curve soon, the probability that we get 9 or above, and we're going to see if it is small under the H0 hypothesis, then surely the probability is so small that we should accept the alternative hypothesis instead, right? Okay guys, so we're looking at the binomial curve. If you guys can see my calculator, we're gonna deal with the right hand side. Basically, it's gonna look like a curve if my pen's worked. Okay, hopefully you can see that. This is a curve, the binomial curve. Now, this is gonna be, let's say 9, yeah? Yeah, this is a curve. Right, and we're gonna use the significance level of 5%, let's say. Alpha is a significance level, 5%. Alpha is 5%, which is 0.05 when we look at the area, right? The probability that x is going to be greater than or equal to 9, if we use a calculator, it's going to be 0.0107. So the probability that we're going to get 9 or above is going to be 0.0107, as stated. We're going to compare that to the significance level, which is 0.05, right? Obviously 0.01, rounded it, is going to be below 0.05. And using our knowledge, right, let's say 0.05 is here, this region. Our probability of getting 9 or above is smaller than the region, the cutoff region. Remember I was saying, you have to have how small are we gonna say that the cutoff should be for us to then say, oh, the probability has indeed increased, right? In favor of the alternative hypothesis, H1. In this case, it has 107 is below 0.05. It's way below there. So the probability of getting this is so small, assuming that p is equal to 1/2, that there's a high probability that it's gone above 1/2. So we can go for the alternative hypothesis and reject this. Of course, hypothesis testing is, you have to use specific language. When making a conclusion, you have to say there's sufficient evidence to reject H0, accept, not reject H0, all of that, and then you have to conclude in context. So in this case, we reject H0. There's sufficient evidence to reject H0 in favor of the probability of getting heads as above 1/2. Now guys, I just want to talk a little bit about one-tailed and two-tailed tests, because that is a big thing that can crop up on your exam. So let's say I didn't actually define, let's say that the probability I claimed would not actually be 1/2. Okay, what do we do? Because I haven't actually stated whether the probability, well, I haven't actually claimed that the probability would have decreased or increased. Obviously, it can be like quite obvious because we got 9. I'm going to be looking at the right-hand side of the binomial distribution, but I have to consider both sides, right? So what we do is we're gonna half the significance level. Okay, 5/2, 2.5, 0.025 will be the new significance level for the right side, well, for both sides, because when you add both of them up, it will be a total of 5%, 0.05. This is just one example, yeah? In this case, it's two-tailed. It's in the name again. Before it was one-tailed. Let's say we got a region to be, the probability to be bigger than the significance level. In that case, we would not reject H0, right? Because compared to the significance level, the probability is not that small. So we can say, yeah, there's a higher probability than the significance level of that happening under the H0 hypothesis. So guys, the significance level that you usually get will be, 10%, 1%, 5%. And in the next video, I may go into the normal distribution, because that is a continuous distribution, and that could be more interesting in terms of finding out values and probabilities. It can help with your revision. Just let me know down in the comments below if you want hypothesis testing, more statistics, If you want the Poisson distribution, the chi-squared test, I can do Yates's correction as well. Just let me know down in the comments below. And again, guys, please remember to subscribe and like this video.